Hello again. So, our next problem states, can the lengths of the altitudes of a triangle be in the ratio 2 to 5 to 6, why or why not? Well, let's say we have a triangle and let's say it has three sides. Lowercase a, lowercase b, lowercase c. Well, we know from our work in altitudes that you can have three possible altitudes in a triangle, one drawn from each vertex. So, let's assume that, and no matter what, your area of a triangle is always the same no matter what altitude you draw. So let's say we have the area of our triangle, and we have like height 1 times the base, which I'll just say is A, over 2. That's 1/2 base times height. So, height 1 is going to be the height that goes down to the base of A. That must be equal to some height 2 or altitude 2 that's drawn from the vertex and hits the base B over 2. And you could probably see where I'm going. The third height multiplied by the base C over 2 is, they're all equal to the same area. Now if we treat this separately, we're gonna, if we think of it, we multiply everything by 2. We have that 2a, 2 times the area, is equal to h1, your height 1 times the base A, your height 2 times the base B, and your height 3 times the base C. Now let's take each pair of heights and solve for, because we want the altitudes. So, and we want them to be in this specific ratio. So let's kind of solve for each side length in terms of its area and the altitude. So, for example, if I'm looking at this pair here, then I can divide by the height 1 and get 2a over h1 equals the base A. And then we can start with this one and get that 2a over the height 2 equals the base B. And then finally, with this pair, dividing the height 3 over, we'd have 2a over the height of 3 equals the base C. Now, why would I set it up like that? Well, because we learned about the triangle inequality theorem, which is all about the lengths of the sides. So now I have an expression in terms of the area and the height, or the altitudes, for each of the sides. And the heights have to be in a 2 to 5 to 6 ratio. So let's say that A would be like the 2 there, in the ratio. So we would have 2a, and our height, our altitude, since it's going to be the 2 in this ratio, is 2 times some number x, and that's equal to a. And for base B, we have that 2a over, well, that's going to be our 5 ratio. It doesn't matter how I assign it. I could have put 2x over with b, just as long as you are assigning the values of the ratios. And finally, we have C is equal to 2 times the area over 6x. Okay. Now, we want to say, is this situation possible? Well, the areas are all the same, so that's good. The x values are the same because our heights are, if they're in this 2 to 5 to 6 ratio, we know there's some number when multiplied by 2, then the other height would be multiplied by 5, then the other height would be multiplied by 6, and we would get the proportionate values. So, let's see, what are the two smallest sides in this triangle? Well, that would be B and C, because every ratio has A and X in it, so those are the same. But if we look at the values in the coefficients, 2 over 5 and 2 over 6 are definitely less than 2 over 2, which is 1, a whole number. So let's test and see if the triangle inequality theorem works. And for that to work, I would need that B plus C would be greater than A, since A is the largest side. Well, we have 2A over 5X plus 2A over 6X needs to be greater than 2A over 2X. Well, adding these fractions together, they have a common denominator of 35. So we have 35x, and to get that common denominator, we have to multiply by 6 over here. So that would be 12a. Plus, we would multiply by 5 over here to get 10a. This is just basic adding fractions. Over 2a over 2x is just a over x. Combining our like terms, we have 22a over 35x is greater than a over x. Well, there is no possible way that this is true, because this fraction 22 over 35 is less than 1, and if you're multiplying by a number less than 1, it's decreasing the value. This is the same thing as 22 over 35 times a over x. That is certainly not greater than a over x. Again, because you're multiplying by this fraction 22 over 35, which would decrease the value of a over x. So, no, it is not possible for those altitudes to have that proportion at all.